We're in section 10.2, and we're comparing numbers 25 and 26. There's similar problems with vectors, but a little bit different method to go about solving them. So if you look at number 25, it's pretty straightforward. It gives you a plane that's flying with a certain direction and with a certain magnitude or speed, and then a wind that's affecting the plane as well, and then we want the resultant vector. So we get the x and y components of the plane by doing the magnitude times the cosine and sine. And then we get the x and y components of the wind by doing the magnitude times the cosine and sine with respect to the positive x-axis. And then we add those two components together and we get the resultant velocity. We get the resultant vector in the x direction and the resultant vector in the y direction. To find the speed, you just go ahead and do Pythagorean theorem with those. And then to find the direction, you do the inverse tangent of y over x, and we get our angle. And north of east, east of north, it's all relative here, depending on what we get. The key is you have to, in all of these, you have to keep track of your axes, and you have to keep track of your directions. So, for this one, this first vector was going negative in the x and positive in the y, so it's going like that. That's the second vector, and then that first vector was going positive and positive, and so it was like this. And so the resultant, if you look, ended up being positive and positive as well. And so the resultant, if you do like head-to-tail addition, is that vector right there. That's our resultant vector. And you need to find the x and the y of that vector. Okay, and just as a reminder, you can always, the head-to-tail addition, what I mean by that is you can always take this and you can put it to here, and then you add those two, you put those two vectors together, and that is where your resultant is. The head-to-tail addition from here to here and then here to here, this is the resultant vector. So then what's different about 26? What's the same about it? Here we have a river that's flowing, and then the canoeist is paddling with the river. So the river's like the wind, and the canoe is paddling. And you have these two amounts. So this part right here is the canoeist's distance, because you have their magnitude times cosine of 135. And then, so then they just go straight to the true velocity here. So what's different is why they don't address the wind is because the river is flowing due east, so it only has an x component. And of course, due east is 2, and it's positive. And so that's why for the x, they have the 2 plus the negative x from the canoeist, because the canoeist is going to the left. All right, so that's the x component. And then the y component is simply the canoeist's amount, because the river is not affecting the y component of the resultant vector. So the resultant vector is this red vector here. And it's the 2 minus that and the 2, that's the y value. Now the book does inverse cosine. For me, I like to stick with inverse tangent. If you did inverse tangent of y over x, you get negative 73.67, and that's because for inverse tangent, it gives it to you in one of these two quadrants. But of course, their direction is here, so all you got to do is take this negative 73 and then find the reference angle here. And so you do the 180 minus 73, and you get the 106.3. And then, of course, to get the magnitude or the speed, you simply do the Pythagorean theorem, square root of x squared plus y squared. And so they're similar. The big difference is that this river only has an x component and no y component. So when you go to combine them, it's much simpler. All right.